Hi, this video for those of you who is interested in selection and breeding, and here is a question: would you expect good nutrition to increase or decrease the heritability of height? And in order to solve this problem, I am going to show you example with plants and fields, because this is very close to what I'm studying. I'm studying plant genetics and physiology. So imagine that we have one field that is divided to different sectors. So we have 3 sectors here, and here we have very high shadowing. So this would give to the plant tallness -1. Here we have minor shadowing, so this would give 0, and the last sector would give us +1, because this is would be full sun, so sunny area. And imagine that we have some variation in genotype of the plants, so it can be between -1 and +1. So some plants are a little bit taller, stronger and better. Other plants have some variation in their genotype, and they just grow smaller. So this variation also would be between -1 and between +1. So what is the worst what we can get? We can get bad parcel of land and bad genetics, right? This is the worst what we can get. So -1 for environment and -1 for genetics, and this would give us total -2. And what is the best conditions that we may have? We may have at the best good sunny area and good genotype, so +1 for genotype, and this would give us +2. So this is going to be our variation between -2 and +2. And this variation would be due to genetics and environment. So here I would like to remind you the formula for phenotype. So total phenotypic variance equal to variance genetic plus variance due to environment. So this is going to be our variance for environment, and this is going to be our variance for genetics of the plants. And total, this is going to be phenotypic variance. So let me write it here. So this is going to be variance environmental. This is going to be variance due to genetic, and this is going to be the last column or row would be variance phenotypic total. Now imagine another situation where we have another such field, but this time the whole area would be sunny and we don't have shadows here at all. So the whole area would be phenotypically uniform and would give us +1 to the plant growth, to the plant tallness. But still we have the same variance for genetics of the plants that we grow here. So variance would be the same, -1 and +1. And what we can get here, at worst we can get +1 and -1, that give us 0. Total would be 0. And what is we can get as the best condition? This would be best genotype and best environment, that would give us +2. So our variance here would be between 0 and 2. As you see, this is going to be much smaller variance here, and now we can use the second formula, and here it is. So variance genetic equal to variance additive plus variance due to epistasis plus variance due to dominance. And the last formula that we need is formula for the heritability. Narrow sense heritability would be h small squared, that equals to variance additive divided by the total phenotypic variance. And now you see that if variance additive would stay the same, as you see, variance here stays the same, and here it is the same as in our first example. So variance additive would stay the same, but variance phenotypic in the second example, where conditions is very good, and this is we can say that this would be good nutrition, and good uniform nutrition would decrease the phenotypic variance. So if this number would stay the same, but this number would be smaller, so that means that good nutrition would increase heritability of the height. In other words, if we try to apply this formula for this example, what we are going to get here, and as you see, the variance due to environment here would be between -1 and +1, and this is going to be 2. So we can put here 2 for the environment variance, and genetic variance, we also can say this is going to be additive. Genetic variance here also would be between -1 and +1. This is going to be 2. So we also can put 2 for the variance genetic. So variance total phenotypic would be equal to 4. So we can put 4 here. And now we just can use these numbers in order to solve for first example. So h squared here would equal to variance genetic or additive, that is going to be 2, divided by variance phenotypic, that is going to be 4. So the answer here would be 0.5. So this is going to be our heritability. And now let's take a look at the second example. Here we don't have any variance at all, so this is only +1. So the variance here would be 0. And we can put variance environmental 0 here. And this is not +1, this is going to be 0. So this is going to be one uniform environment. So no variance at all. And variance genetic would be the same between -1 and +1. So this is going to be 2. And we can put 2 here. So total phenotypic variance here would be 2. So our formula this time would look like this: h small squared, variance genetic or additive, that is going to be 2, divided by total phenotypic variance, that is going to be also 2. So here our answer would be 1. And as you see in the second example, our heritability increased in comparison with the first example, and this is our answer. And also we can say that in this example today we can ignore variance due to epistasis and variance due to dominance, and in this case variance additive would equal to variance genetic. So just in order to make things easier for you to understand, so we can ignore just these two variances. And as you see, once again, the good condition, good nutrition, would increase heritability. And this is two formulas and two examples that I show you today that prove this concept. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. See you in the next video. Goodbye.